Hi everyone! Today we're going to learn how to graph polynomials. In order to be able to graph a polynomial, we have 4 different steps that we are going to go over each of them today and learn how to graph a polynomial. The first step is to find the end behavior. In order to find the end behavior, we are going to use this table that you see here. Let's work with an example. X to the power of 3 minus 2x squared plus 5, for example. In order to find the end behavior, the first thing that we need to do is to find the degree of this polynomial. The degree of this polynomial is 3 because it's the term with the highest exponent. So you take the exponent of the one with the highest exponent, that's 3. And then we need to find the leading coefficient, which in this case is 1. So 1 is the leading coefficient. Then look at this table. It says if your degree is odd and the leading coefficient is positive, then you're here. You need to remember y equal to x for this case, because the end behavior of y equal to x is going to be similar to the end behavior of this given polynomial. Y equal to x has a graph like this, and you see the end behaviors are this way and this way. So I'm going to copy the end behavior here. So this will be the end behavior of my function. That means if x is going to infinity, y is also going to infinity. X is going to negative infinity, y is also going to negative infinity. So that's the end behavior. This means if you have a polynomial and the degree is odd and the leading coefficient is a positive number, you need to think of y equal to x, because the end behavior of this polynomial is going to be similar to y equal to x. The next example is negative x to the 3 minus 2x squared plus 5. In this example, degree is 3 and the leading coefficient is negative 1. You see there is a negative here. So in this case, that the degree is odd and leading coefficient is negative, you need to think of y equal to negative x. The graph of this function looks like this. So the end behaviors are this way. I'm going to copy the end behavior here. The end behavior of this polynomial is similar to y equal to negative x. So as x is going to infinity, y is going to negative infinity. X is going to negative infinity, y is going to positive infinity. So this is the end behavior of this polynomial. Now let's work on another example. Let's say I have 4x to the power of 6 plus 9x squared minus 3. Degree of this polynomial is 6 because this one has the highest exponent and the leading coefficient is 4. So in this case, that the degree is even and the leading coefficient is a positive number, I need to remember the end behavior of y equal to x squared. The graph looks like this, a parabola. So the end behaviors are this way and this way. It means both end behaviors are going to infinity. Another way to write the end behavior is this form, which is limit. It's called limit. So I say limit of f of x as x is going to negative infinity is positive infinity because my y is going to positive infinity. And limit of my f of x as x is going to positive infinity, again here is positive infinity. So basically the idea is the same as the end behavior that we had, it's just a different form of saying that. Now another example, I have negative 5 x to the power of 4 plus 3x minus 9. In this case, the degree is 4 and the leading coefficient is negative 5. So you see that degree is even, leading coefficient is a negative number. So we need to think of y equal to negative x squared this time. We have a negative x squared. The graph looks like an upside down parabola. So the end behaviors are going to be similar to this one. As x is going to negative infinity, y is going to negative infinity. X is going to positive infinity, y going to, again, negative infinity. So in order to find the end behavior of any polynomial, you need to find the degree and the leading coefficient. And based on this table, you need to know which function to remember to figure out the end behavior of that polynomial. Now let's go to the next step, which is y-intercept. In order to find the y-intercept, it's easier to find the y-intercept before factoring because you're just going to replace 0 for x and solve it for y. So here I'm just going to replace 0 wherever I see an x. Negative 4 0 squared plus 3 0 minus 7. So all these are going to be 0 because 0 times anything is 0. So negative 7 is left. My end behavior will be 0 and negative 7. I'm sorry, my y-intercept will be 0 and negative 7. Let's do some examples here. I have these two polynomials and I want to find the y-intercept of them. So this example has the polynomial in factored form. Again, we're going to do the same rule. Set the x equal to 0 and solve for y. So I plug in 0 for x, 0 times 0 minus 2 squared times 0 times 3 minus 4. And this is just equal to 0 because 0 times anything is 0. So my y-intercept is 0 and 0. In this case, again, we want to find the y-intercept. You set the x equal to 0 and replace it here. It's going to be 0 plus 3 squared and 3 times 0 minus 1. So this will be 0 plus 3 is 3, 3 squared is 9, and then the next parenthesis, 0 times 3 is 0, minus 1 is negative 1. So 9 times negative 1 is negative 9. My y-intercept here is 0 and negative 9. So this is how you find y-intercept if your polynomial is in the factored form. Now let's go to the next step, which is finding the x-intercept. It's easier to find the x-intercept when your function is in the factored form this time. So if your polynomial is not in factored form, try to factor it first, then find x-intercept. Why? Because in this case, you can just set each factor equal to 0 and then solve for x. For example, here we have a polynomial with 5 different factors. To find the x-intercept, I'm just going to set each factor equal to 0. The first one is this x. So I set that equal to 0 and my x-intercept is 0 and 0. The next one is x minus 3. So I set the factor equal to 0 regardless to the power. I'll just take care of the factor and set that equal to 0. From here, x is equal to 3. Then my y-intercept, my x-intercept will be 3 and 0. The next factor is x minus 2. X minus 2 equal to 0. Then x will be equal to 2. And 2 and 0 is my next factor. my next x-intercept. Then x plus 7 equal to 0. X will be negative 7, and negative 7 and 0 is another x-intercept. So here I have 4 x-intercepts. All these are my x-intercepts. Now let's go to the next step. So far we have learned how to find the end behavior, x-intercept and y-intercept. We know that x-intercept has another name as zeros. So let's say I have given you a function. Let's say I give you a polynomial and I tell you to find x and y-intercept, and you find x-intercepts and y-intercept. Let's say you're gonna say, okay, in my graph, this is one of my x-intercepts, this is another one, and this is the other one, and the end behaviors are like this. So this is actually what we have learned so far to figure out about the polynomial, but we don't know what to do with these x-intercepts. Like, we don't know what is the behavior of my function in these zeros. It could be this way, it could be this way, or any other way. We don't know which one is the right one. So this is what we're going to learn right now in the next step. So in step 4, we're going to learn the behavior of the polynomial at zeros or x-intercepts. In order to be able to figure this out, first we need to know the multiplicity. What is multiplicity? That's exponent of the factors. Like for each factor that we have, if we take the exponent of the factor, that's the multiplicity of that factor. Like for example, in this example, multiplicity of x is 1 because the power is 1. Multiplicity of x minus 3 is 3. X minus 2 is 4. X plus 7 is 1. So these are the multiplicities of the exponents, and also we call it multiplicity of the zeros because we have 0 here and another 0 here, which is 3, another 1 here, which is 2, another 1 which is here at negative 7. So these are the multiplicities of the zeros. Now what do I do with these multiplicities that we just figured out? Here's what we're gonna do with them. Here is how we are gonna use them to figure out the behavior of the polynomial at zeros. So if multiplicity of a factor or a zero is 1, means the exponent of that factor is 1. This means my graph is just going to cross that point. How? Like this. So let's say this is my graph that is passing through this point. This is a 0 of my function. Because multiplicity is 1, my graph is just going to cross this line. So it's going to be something like this. Or it could be something like this. Let me draw it somewhere else, like here. So let's say here it's going to cross this way. It could be either of them. It's just about crossing from one side to the other side. If the multiplicity is an even number, that means your graph is bouncing at this point. Okay. It's gonna be something like this. Let's say my 0 is here, so it's bouncing. It means it's getting close to this point and then bounces back, going up. Or if the function is the below of the x-axis, it could be like this. Whatever it is, it's going to bounce, go up and then come back. What if the multiplicity is odd and it's not equal to 1? Like something like 5, 7 or anything else. In this case, your graph is going to wiggle at this point. Means something like this. This is the point that I have the 0, and it's going to wiggle like this. This is called wiggling. So these are the behaviors at these zeros. Now we're going to do one example. I'm going to use this polynomial and graph this polynomial. Okay, here I open a new page to work on the example that we had on the other page. So this is my polynomial. As we just thought about this, the first step is to find the end behavior. So in order to find the end behavior of this polynomial, we need to find the degree and the leading coefficient. The degree of this polynomial is 9. Why it is 9? Because in order to find the degree of a polynomial which is in a factored form, you have to add all the exponents of the factors. So you take them and just add them. So this is 1 plus 3 plus 4 plus 1, which is equal to 9. So the degree of this polynomial is 9. So once again, keep in mind, if your polynomial is in factored form, you just take the exponents of all the factors and add them together. Then we need to find the leading coefficient. If your polynomial is in factored form, you find the leading coefficient by taking the leading coefficient of each factor. Like this one is 1, so I'm going to write 1 to the power of 1 multiplied by the leading coefficient of the next one, which is 1 to the power of 3. Then leading coefficient of next one to the power of 4. Leading coefficient of the next one to the power of 1. So leading coefficient of each factor raised to the power of that, and then multiply all of them together. In this case, since everything is 1, 1 to the power of anything is 1, and multiply by any 1 is again 1. So the leading coefficient is 1. So the rule is to take the leading coefficient, raise to the powers, and multiply them. But usually on your assessments, we're going to see examples like this that have all ones on the the coefficients. So the leading coefficient is 1. Now I have an odd degree and a positive leading coefficient. This means I need to go back to my table. If the degree is odd and the leading coefficient is positive, then I have to remember y equal to x. That is the end behavior of my function. So I'm going to remember y equal to x, and the end behavior is going to be similar to y equal to x. So this is my end behavior. The next step was to find the y-intercept. We said in order to find the y-intercept, just set x equal to 0 and then solve for y. So wherever I see a 0, I'm going to replace it here. 0, 0 minus 3, 0 minus 2, and 0 plus 7. Okay? So here, 0 multiplied by anything is 0. Even though the powers were 4 and 3 and 1 here, we don't care about the powers because 0 multiplied by anything is 0. So my y-intercept is 0 and 0. Then we need to find x-intercept. If your polynomial is in factored form, it's going to be much more easier to find the x-intercept. So you set each factor equal to 0. The first factor is x. So x equal to 0, and from here 0 and 0 is my x-intercept. The next one x minus 3 equal to 0. So x will be 3, and 3 and 0 is my x-intercept. Then x minus 2 equal to 0, x is equal to 2, and 2 and 0 is my x-intercept. Then x plus 7 equal to 0. Then x equal to negative 7. So I'm going to write negative 7 and 0 as my x-intercept. So all these are my x-intercepts. This is my y-intercept, and this is my end behavior. The last thing that I need to figure out is the multiplicity of all these zeros and the behavior of the function at these zeros. So multiplicity of each of these. For x equal to 0, which comes from this factor, the exponent is 1, so multiplicity is 1. X minus 3, exponent is 3. That's multiplicity. Exponent is 4 for x minus 2. So that's 4. And the last one, x plus 7, comes from here. The exponent is 1. So the behavior of the function for each of them. We said if multiplicity is 1, your function is just crossing. I'm going to write it as just C. This means crossing. If it's an odd number, it will wiggle at this point. If it's an odd even number, so if it was odd, it was wiggling. If it's even, it's bouncing. Again, if it's 1, it's crossing. So I have all the information that I need to be able to graph this function. Okay, so let's start with the y-intercept, which is at 0 and 0. So I'm going to mark it here. This is my y-intercept at this point. And then x-intercept is at 0 and 0, which is the same place as this one. 3 and 0, so it's going to be, let's say this is 1, 2, and 3, so it's here. The other one is 2 and 0 here. And the last one is negative 7 and 0. Let's say negative 7 is here. Now we are ready to graph the function. We know that the end behavior is looking this way. So it's going to be this way here and this way here. Now we're going to start from the left side of x-axis. The first thing that comes here on the left side is negative 7. On negative 7, multiplicity is 1 and my function is just crossing. Since the end side of my function is already here, downside, and my graph has to cross this point, means it's going to cross from this side, which already was here, to the other side. So it's going to be this way at this point. Then we have 0. At 0, again, multiplicity is 1 and behavior is crossing. So it has to go back to this side and cross this point. Then at 2, multiplicity is 4. That means it's going to bounce at this point. Means it has to get close to this point, touch it, and then bounce it. So the graph has to be like this. From this side goes back to the up, and then bounce, and then goes back down. The next one is 3. At 3, multiplicity is 3, and the behavior is wiggling. So it has to be a wiggle form. Let's do it like this. You see, it's wiggling. And it's going to be like this. So this is the graph of my polynomial. Make sure you practice a lot to perfectly learn this subject. Have a great day.